Hey everyone, Dr. Crahay here. In this Chapter 5 lecture, I'll be talking about measurement validity. One quick note, reliability, what I talked about in one of the last lectures in this chapter, it's a necessary but not sufficient part of validity. So in other words, you need to have reliability for a test to be considered valid, for evidence for validity. So reliability is a necessary component. It's not the only thing that you need, but it is a big piece of it. So before you start this lecture, please do take the time to go through that reliability lecture. So with validity, we're asking, does the measurement measure what it is supposed to measure? There are a couple of different ways to do this: face validity, content validity, criterion, convergent, discriminant, and then of course we'll discuss briefly the relationship between reliability and validity. One major problem that we have as psychologists is that we measure a lot of abstract constructs. So for example, happiness keeps coming up. There's no way, we can't just take your blood and find some biological marker of happiness. We're interested in these very abstract constructs. So validity can be very difficult to find, but that makes it all the more important. We want to make sure that we're measuring what we say that we're measuring. So returning briefly to our concept map from the textbook, you can see reliability there towards the kind of top right of this little graph here, figure rather, and then you can also see all of the different validities down there in the bottom left. And so we'll talk about each of these in turn. So first we have two rather subjective components of validity. Those are face validity and content validity. With face validity, we're asking, does it look like a good measure? Usually you'll go to an expert in the field. Maybe you'll go to a quantitative psychologist, someone with expertise in measurement, and you'll have them look over your measure and say, does this look like a good measure? That's face validity. Content validity is concerned with whether or not the measure includes all of the important components of the construct. So say, just to keep running with this happiness example, say we've determined in the research literature that there are 5 components of happiness. So in our happiness scale or happiness measure, have we included all 5 of those components? If we have, then we have evidence for content validity. Typically you'll want to go to someone with expertise in that field. So if you wanted to make a measure on flashbulb memory, you would come to someone like me. For something like happiness, you would want to go to someone that does research on happiness, probably a personality psychologist. So with face and content validity, they're really very subjective. It's someone kind of giving a yes or no, do they approve of this or not. With criterion validity, we're starting to get towards a more empirically data-based validity measure. So criterion validity is looking for a relationship between your measurement and some kind of behavior or similar concrete outcome. So here we have 2 different scatter plots showing the relationship between some kind of measurement there on the bottom in the x-axis, and then some kind of behavior or measurable outcome on the y-axis. So here we have on the left, example A, we've given people some kind of sales ability test, and then we're looking at that test score and its relationship to sales. So if you score high on some kind of measure of sales ability, you should in the real world have a lot of sales, right? So this is just another correlation. So we're doing the same thing here, but criterion validity, we want to see that relationship between the measure and some kind of behavior. So you can see here, again, if this purple line wasn't here and I asked you to try to draw a line of best fit so that best represents the pattern here, I think we could all do that fairly easily and we would come up with a very similarly placed line. It's a pretty strong relationship. Again, the correlation is going to be very close to a perfect 1.0. So you have pretty strong evidence of criterion validity here on the left. On the right, example B there, we have the relationship between IQ score and sales. So here we're saying, does IQ score lead to higher sales? So smarter people can sell more. If you're looking at the pattern of orange dots again here, it would be much harder to draw this purple line. There isn't a clear trend, there's no clear relationship, so you know that correlation is going to be closer to a 0. So that's not very good evidence for criterion validity. I would not say that IQ score is a good measure of sales. We just don't have the evidence for criterion validity here. In the last slide, when discussing criterion validity, we looked at a correlational method. So that's what we're used to. We want to know the relationship between two different measures, or a measure and a behavior, or whatever the specific instance is. We can also investigate criterion validity using the known groups method. So what this is doing is basically you give people a measure and you already know their classification. So the example here is that you have a group of depressed people, a group that are not depressed, and that is judged by, I think they had a handful of psychiatrists that made these diagnoses. You also have your BDI score, so BDI stands for the Beck Depression Inventory, so higher scores reflect higher levels of depression or more symptoms of depression. And so what should work out when you graph these out in this bar chart like we've done here, you should see that depressed people score higher on the BDI than non-depressed individuals. In that case, you would have pretty strong evidence for criterion validity. So that's exactly what we're seeing here, right? So you can see depressed people had higher score than not depressed people had the lower scores. So you can see the measure has a pretty strong relationship with some kind of observable behavioral outcome. Digging a little bit deeper with the known groups method, we could even look at psychiatrists' rating of the severity of depression. So in the last graph, we just looked at depressed versus not depressed. But there's also a question here, if someone is severely depressed, is not functioning in daily life, theoretically they should have higher scores on the BDI than someone with a very mild depression. So that's what this graph is looking at. So here, same thing, psychiatrists rating, no depression, mild, moderate, severe, and you can see those BDI scores increase the way that we would expect with our known groups. Two more data-backed validity techniques are convergent and discriminant. So with convergent validity, you want two measures to be very similar in their scores. So if your measure is a depression score, people should score very similarly on a different, already established depression scale. So your depression scale should match well with the BDI, for example. That would be evidence for convergent validity. Discriminant validity, on the other hand, you don't want your measure to have a relationship with something that's unrelated. So if you have a measure of depression, you don't want that to be related to a measure of physical health is the example that we use here. So let's just start there. So in this right scatter plot, we have the BDI, so the Beck Depression Inventory total scores on the bottom there, and then we have the physical health score on our y-axis. So if we have evidence for discriminant validity, there should not be a clear pattern here. There should not be a clear relationship, because your measure is looking at depression, not physical health. Now there's some overlap between those two, but not perfect overlap. I wouldn't even say it should have a strong overlap. So that's what we're seeing here, right? So if I asked you to draw a line through the pattern of these scores, a line of best fit to represent every point of data, that would be very difficult to do, and we would all have different lines. So this is evidence for discriminant validity. If you could draw a line through this graph, so again, we're graphing something, depression with something that should not be related. We don't want any kind of relationship. If there was a clear pattern here, then we would have a problem. The fact that we don't gives us evidence for discriminant validity. I know that's a little bit backwards than the way that we usually think about things, but with a little practice, you'll get used to it. So going back to convergent validity, again, we have two different measures that are looking at the same thing or very similar things, and we want there to be a relationship. So my new measure of depression should correlate with the old measure of depression, the Beck Depression Inventory, something that's well established. So that's what we have here. On the x-axis, we have our BDI total score again. On the y-axis, we have the CESD total score. So that's the Center for Epidemiologic Studies Depression Scale. So it's just another scale that's out there measuring depression. And here you can see a very strong relationship. If I asked you to draw a line to highlight the pattern, I think we could all draw one and it would be fairly close. Those lines would be fairly close in slope and the y-intercepts. So we can see a clear relationship there. We know that correlation is going to be closer to 1. Of course, it's not going to be perfect, but I bet we would hit that cutoff of 0.7 that we want to see for reliabilities and those kinds of things. So there seems to be a relationship here between these two measures, so that's evidence for convergent validity. Looking at the scatter plot on the right, we do not see a relationship between the BDI and physical health, which is actually evidence for discriminant validity. Okay, so looking at the relationship between reliability and validity, can a measure be reliable but not valid? The answer is absolutely yes. So say that we're using shoe size as an intelligence test. So, the bigger your shoe size, the smarter you are, something like that. Every time you test your shoe size, assuming that you're an adult, your shoe size will be very similar across different measurements. So test, retest, right? That will be evidence for reliable. However, we know that there is no relationship between shoe size and intelligence, so it would not be valid. The number of children you have as a measure of interest in children, okay, you can reliably measure that, okay, the number of children you have, but is it correlated with interest? So it might be a little bit, but not necessarily, right? So the next question we have here, can a measure be valid but not reliable? And the answer is absolutely not. So we want to know that the test is measuring, what it says that it's measuring, but if the results are just all over the place, then, we don't have evidence for that. So reliability is a necessary component of validity, but of course it's not the only component. So you have to have it and then a little bit more. And so here we have a couple of visual depictions of reliable and valid, reliable but not valid, and then not reliable and not valid. So you can see reliable and valid right on the target, clustering really closely on that target. We could be reliable but way off, so that's like the shoe size. We're always getting the same shoe size, but we're not measuring what we wanted to measure. And then of course not reliable, not valid. So it's all over the place. We're measuring a lot of different things, but it's very rarely that thing that we tried to measure. So again, reliability is a necessary but not sufficient component of validity. So you need reliability to establish validity, but then you have to take a couple of extra steps.